That is called a perfect square trinomial. So please jot the following in your notes. We will know if a trinomial is a perfect square.
It's 8.5.
Yes. So a trinomial is a perfect square if the following is true.
So we say the following is true?
Well, now, so you're going to write this. Are you ready? Here is the first.
So we're going to draw these.
Well, you're just going to write this out. So a trinomial is a perfect square if the first and last terms are perfect squares. We just talked about perfect squares and what those look like. So that's the first thing we're looking for. The first and the last terms need to be perfect squares. It's our first check off. Yeah.
Where's that college?
Didn't we already have this discussion at the beginning of class? Pennsylvania. Elizabethtown, Pennsylvania.
We had that
Are they sponsored?
Huh? Are they what?
Sponsored by Untitled?
No, I don't know.
Yeah, they are.
Is that where you went?
There's Under Armour sweatshirt.
Is that where you went?
Yes. I went and played field hockey there.
So it's in New Jersey?
Pennsylvania.
Oh, Pennsylvania.
That's where I'm from.
Oh.
Center mid. All right, next bullet.
Yeah, pretty center mid.
So the first and last terms are perfect squares. The next thing we're checking for is that the middle term is 2 times 1 factor from the first term and 1 factor from the last term. Now it can be a little confusing. It's easier to see it in practice. Okay, so now let's quickly think about this. If my first term, let's say, is 4, okay, the factors of 4 that I'm looking at are 2 times 2, right, because 2 times 2 is 4. So if I take just one of those factors, I'm focusing just on the 2. If my last term, let's say, was 9, the factors of 9 would be 3 and 3 to make it the perfect square. If I focus on just one of those, the factor would be 3. So the middle term has to be 2 times 1 factor from the first term, so 2, and 1 factor of this last term, 3. 2 times 3 makes 6. So if I do 2 times that, my middle term would have to be what number? 12. Okay, so let's see what this looks like. I'm going to give you a trinomial, and we're going to decide whether it's perfect square or not. So write the following down. 9x squared minus 15x plus 64. We're going to decide, is it a perfect square trinomial or not? First check off. Is the first and last term perfect squares? Yes. Okay, well that was easy to see. Now we have to check the middle term.
Nope.
So the easiest way to think about it is, what's the square root of 9?
3.
Oh, why am I in that mode? 3. The last number is 64. The square root of 64 is 8. So if I take 3 times 8 and then multiply it by 2, what do I get? I get 3 times 8 is 24. 24 times 2 is 48. Is that your middle term? No. So this is not a perfect square trinomial for now. If it was, then we would be able to factor it, but we'd be able to factor it very easily. So it's not a perfect square trinomial. Okay?
Because the middle term was
48. If it was 48, then it would be a perfect square trinomial. All right, let's look at another one. Write down 81x squared plus 90x plus 25. First and last perfect squares? Yes. So now the tricky part is checking that middle term. So the square root of 81 is 9. Square root of 25 is 5. So if I multiply those, multiply it by 2, do we get the middle term? So 90 is the middle term. So we would say yes, it's a perfect square trinomial. Now let's factor it and then see if you can figure out what the shortcut would be after we factor it.
But
Wait, so if it's not a perfect one, you don't have to factor it?
Well, it may be factorable, it just won't be a perfect square.
But you still have to factor it.
Yeah, or try to.
I have a question. The two outside ones are perfect, but the middle one isn't.
Right, that's true.
So how is it a perfect?
Well, I'm going to show you. We're going to factor it and see what it looks like. All right, so let's use rainbow method on factoring. Can I erase this part to give myself more space?
Sure why not?
All right, so first times the last. Oh my goodness. 81 times 25. Let's do it. That is disgusting. That's why we want to learn the shortcut so we don't have to do this. 81 times 25 is 2,025. All right, so factors of that add up to 90. I'll help you out. 45 and 45. Okay. So now let's factor by grouping, which we have been doing. So 81x squared plus 45x plus 45x plus 25. Group the first two. Give me a GCF.
9.
And x. So now I'm left with 9x plus 5. GCF of the last two. 5. So now I'm left with 9x plus 5. So my factors are what? 9x plus 5 times 9x plus 5, which we said could go to
9x plus 5.
9x plus 5 squared.
I'm so confused.
Yeah, so what's the shortcut? Didn't we say the square root of 81 was 9? Square root of 25 was 5. Why do you think this is a plus?
Because they're both positive.
The middle term is positive. If this was minus, what do you think this would be? A minus, right? Okay, but this only works for perfect square trinomials. That's why you need to check, does it work for the middle term? Does 9 times 5 times 2 make the middle term? If it does, then you can jump right to that shortcut and get your answer.
So we don't have to do the word if
It's perfect square trinomial. Yep, if you remember how to do it correctly. Okay. Again, you should probably always check to make sure that it does work out. So then I would rewrite it and do my double distribution or foiling and see if I get back to the beginning. All right, let's look at this one. See if this one works. 36x squared minus 10x plus 14. What do you think? Is it a perfect square trinomial, yes or no? Why not?
14 sounds good.
Not a perfect square.
Come on, nice drive.
So it is not a perfect square trinomial. Okay. So far, so good. All right. We won't do the word problem. Let me just do the actual problem. See if you can do the shortcut. So just rewrite. Don't write any of this stuff. Just rewrite this on your paper. So 16x squared minus 24x plus 9. So can you factor it using the shortcut?
But does it work if the middle term's negative?
Yep. So the square root of 16 is 4. The square root of 9 is 3. 4 times 3 times 2. Is that your middle term?
Yeah.
Yep. So it is a perfect square trinomial.
No, but how does it work if that middle term is negative?
It just makes a minus in between.
4x minus 3.
Good. Squared.
Yeah.
Good.
Okay.
4x minus 3 squared. Okay, again, this is a shortcut. Could you still factor that using our factoring rainbow method? Sure, you could. Okay, but this is a shortcut to maybe get you there quicker. So the first clue that you should be looking for is if you're given a trinomial where the first and the last is a perfect square, then you should be thinking, maybe that middle term would make it a perfect square trinomial. And then go for it and see if it does. If it does, then go right to your shortcut. All right, that's our first shortcut. Second shortcut is going to get us into something that's called a difference of squares. What do you think a difference of squares looks like? Where's my, marker. If I gave you something like this, x squared minus 4. Is x squared a perfect square? Yeah, we said the square root of x squared was what? X. Is 4 a perfect square? Yes. If I were to factor this using the rainbow method that we know how to do, my first term here is a 1 times my last, which is negative 4. What is the middle term if there's nothing there?
0.
0, right? So, factors of 4. 1 and 4, 2 and 2. Which one of those gets you a sum of 0? So if you were to write that out in its factors, what would it look like? X plus 2, x minus 2. Okay? That'll work every time. If I turn this into a minus 16, what do you think it would be? Plus 4 minus 4. If I put a 9 out in front, what do you think would change? I would put 3 where? In front of the x, right, Marshall?
Oh, do you want to, like, for the first one, where it's x squared minus 4, why would you want to factor that? It's already like so small.
Because you want to write it in factored form. And what we're going to be getting into is solving quadratics, and you can solve a quadratic once you have something in factored form. So you need to be able to factor it first before we get to the actual solving of quadratic
Like, I'm not trying
equations.
to do it, like, when do you use that?
Huh?
When do you use
So
that?
anything, so quadratics make parabolas in their shape. So anything that goes up and comes back down is a quadratic equation. So a lot of times in physics. All right, so this is called a difference of two squares, which should be your favorite. If you have a difference, meaning it has to be subtraction of two squares, then we can go right to this rule of thumb. So I have a squared minus b squared. So anything squared minus anything squared is going to be equal to the square root of a squared is a, square root of b squared is b. So you're just going to do an a plus a b, and you're going to do an a minus b. These always have to be opposite in sign because you need that middle term to cancel out. If I were to multiply this out, I would get a negative AB and a positive AB, which would cancel. Okay? And whenever you do your last times your last, you're going to get a negative b squared. So that's why it only works with difference of squares and not sums of squares. Okay? So you actually can't factor sums of squares. All right, so here's our first one. Is the binomial a difference of squares? Well, first, is it a difference of something?
Yes.
Yes. Do I have perfect squares? This is 9np to the fourth is any exponent to an even can be a perfect square. So you can always take half of any exponent that's an even. The 3 in this case is not. So the 3 is the problem. So that is not a perfect square. So the whole thing is not a difference of squares.
Wait, how is it not a perfect square?
3 is not a perfect square. You can't take the square root of 3 and get an integer answer. Okay? If 3 wasn't there, then we'd be good to go. We could factor it. All right, let's do one that is a difference of squares. 100x squared minus 4y to the fourth.
4y to the fourth is?
Is 100 a perfect square?
Yeah.
The square root of 100 is 10, square root of x squared is x. Square root of 4y to the fourth would be 2y squared. So then all you need to do is rewrite those with a plus and a minus. So 10x plus 2y squared, 10x minus 2y squared. Difference of squares. Okay. All right. Let's do one more. X to the fourth minus 25y to the sixth. Is it a difference of squares? Yes. Again, like I said, any exponent that is an even number, you get a perfect square because you can take the square root of it, which is just the same thing as cutting it in half. So, the square root of x to the fourth is x squared. The square root of 25y to the sixth would be 5y to the third. And then you're just going to put either a plus or a minus first, doesn't matter. Just make sure you have opposite signs. Okay? All right, it's your lucky day. I put a Kahoot together. Grab a Chromebook.